let's talk about induction and go over a couple of examples. So induction method is a method that we use to prove some mathematical formulas. Sometimes you can apply induction to inequalities as well. So the method of proof by mathematical induction. In this method of proof, you're going to deal with a statement. We try to prove a statement like P of n. This statement can be anything. For example, suppose you try to show that 1 plus 2 plus 3 plus the very first n natural numbers, the sum of the very first n natural numbers is equal to n times n plus 1 divided by 2. So at the same time, I write down one example for you so you feel comfortable when you're applying this method. The very first step is called the basis step. So know the name of these steps. Basis step. In this step, you're going to take the very first element in the domain. So if A is the smallest value in the domain, you're going to work with that guy. Check if P of A is true or not. Okay, this is your very first step. So take a look at this formula. This formula starts at 1. So you're going to take the very first element and check to see if that element satisfies the formula or not. So what's the meaning of that? It means that, hey, on the left-hand side, I have 1. On the right-hand side, n is equal to 1. So 1 times 1 plus 1 divided by 2, left-hand side and right-hand side they need to be equal to each other. If you simplify this, 2 and 2, they get canceled out. So left-hand side and right-hand side, both of them are equal to 1. It means that the basis step is correct. The basis step is true. It means that you're allowed to go to the next step. In the next step that we call inductive step. Inductive step. You're going to assume that your statement is true for any number less than or equal to a n. So assume that the statement is true for any value like k less than equals to n. So what's the meaning of that? We assume that pk is true. This is our assumption. Then we try to show that p of k plus 1 is true. Okay, so take a look at the formula. What is pk? Pk in the inductive step is going to be the sum of very first k natural numbers. So 1 plus 2 plus 3 plus k is equal to k times k plus 1 divided by 2. This is our assumption. This is our assumption. Now we're going to show that this statement is true if we replace k by k plus 1. Now, we show that it is true if we replace k by k plus 1. Okay, so you have a formula. You're going to show that 1 plus 2 plus 3 plus k plus 1 is equal to, wherever you see k or wherever you see n, you're going to replace that by k plus 1, the last term. This is going to be your last term. So your last term here is going to be k plus 1, parentheses, k plus 1 divided by 2. So this is our goal. We want to show these left-hand side and right-hand side, these two statements are equal to each other. Okay, very good. There are different methods, different ways showing that these two are equal to each other. What are you going to do? You can use this assumption that 1 plus 2 plus 3 plus the rest of the terms plus k is equal to k times k plus 1. You can use this and replace it for the sum of the very first k elements, all right? You know that 1 plus 2 plus 3 plus k is k times k plus 1 divided by 2. So replace that here. Use the formula that you already have. Okay, let's see. So I get k plus 1 divided by 2 plus the rest of the terms. Plus k plus 1. Now take common denominator. Common denominator. Okay, if I take the common denominator, it's going to be 2, am I right? This is equal to 2k times k plus 1 plus 2 times k plus 1, just pure algebra. Now, if you factor out k plus 1 on the numerator, you end up with k plus 1, parenthesis, if you take out k plus 1, here you're left with k plus, if you take out k plus 1, you're left with 2, divided by 2. Now compare these two statements, these two fractions here. Are they equal to each other? Yes, I just showed that left-hand side and right-hand side are equal to each other. What's the meaning of that? It means that I just showed that P of k plus 1 is also true. So what's the conclusion? The conclusion is, well, by using the induction, method, we showed that Pn is true for any n. So we just showed that this formula is true for any n. This is our conclusion. So at the end, we're going to write down, hey, by the method of induction, we showed that 1 plus 2 plus n is equal to n times n plus 1 divided by 2. Just prove this nice formula by the method of induction.